Hi all, welcome to my channel Teach Me Physics by Nitadas. Today we can see kinematic problems, how to solve them using the big four equations. Let us start. Today we can check some of the examples regarding kinematic equations. In the part 1 we have discussed four kinematic equations. Today we can see examples of numerical problems, how to solve these kinematic uh, problems using these kinematic equations. So first example, Sam accelerates from 12 meter per second to 26 meter per second at a rate of 4.2 meter per second square. Over what distance does this occur? From the question, it is clear that what all things are given here. Here, Sam is accelerating from a velocity that is 12 meter per second to a velocity of 26 meter per second. So from this we can understand initial velocity is Vi is 12 meter per second and final velocity is 26 meter per second. Then the rate of acceleration, that means acceleration is given from the unit. It is understood. It is in meter per second square. So it is acceleration. So acceleration is given as 4.2 meter per second square. So we need to find the distance. Out of the four kinematic equations, the equation for finding distance is there here. V final square is equal to V initial square plus 2AS. And if we use this equation, you can find S. S stands for distance. So on rearranging, we can write as 2AS is equal to VF square minus VI square, and S is equal to Vf square minus Vi square divided by 2 times A. Now substituting the values of these variables, we get 26 square minus 12 square divided by 2 times 4.2 meter per second square, which on simplification or calculation we get the value of distance is equal to 63 meters. So Sam took like a 63 meters distance is covered during the change of velocity from 12 meter per second to 26 meter per second at a rate of 4.2 meter per second square. Now, let us move to example number 2. Bob is traveling at 32 meter per second. That is the velocity. When you notice this unit, you should understand that it is the speed or velocity. And when he sports the state police, he was traveling at 38.2 meter per second. So he decelerates at a rate of 8.6 meter per second square for a time of 2.1 seconds. What distance does he travel during this time? So the data given here can be written down as this is his initial velocity and he decelerates. So we don't know the final velocity. So initial velocity V0 is given here, or Vi. Initial velocity Vi is equal to 38.2 meter per second. Then, as he is decelerating, acceleration is a negative value because speed is decreasing here. So it is minus 8.6 meter per second square, and the time is 2.1 second. So here also the distance is asked. So the kinematic equation that have these variables and along with the distance is S is equal to Vi t plus half a t square. So substituting the values, Vi is 38.2 times 22.1 second plus half times minus 8.6 meter per second square times 2.1 square. On solving, we get S is equal to 61 meters. So Bob, when he started decelerating at a rate of 8.6 meter per second square from a velocity of 38.2 meter per second, in a period of 2.1 seconds, he traveled a distance of 61 meters. Now, let us move to the third example. What is the acceleration of a car that brakes from 24.2 meter per second to 11.9 meter per second in 2.85 seconds? So from the information given in the question, we can identify acceleration should be found out, and the initial velocity as well as final velocities are given, time is given. So let us write down the data given here. So V initial is 24.2 meter per second. V final is 11.9 meter per second, and T is equal to 2.85 seconds, and the equation that connects these variables along with acceleration, the kinematic equation is V final is equal to V initial plus A times T. So substituting the variables in the given equation, we can find acceleration. So on rearranging, we get acceleration, sorry, A t is equal to Vf minus Vi, and A is equal to Vf minus Vi by t. Here we kept A times t in the left hand side and it took Vi to the right hand side and written here. So substituting the values, we get Vf is 11.9 minus 20. Sorry, that was a mistake. Let me correct it. Vf is V final is 11.9 minus V initial is 24.2 divided by time, that is 2.85 seconds. As we are subtracting bigger value or a bigger number from a smaller number, the answer will be a -1. So the answer is minus 4.32 meter per second square. That is the value for accelerations. As it is negative, we can understand that he is decelerating. Thank you for watching. See you next time with a new video.